All right, so what do we know? What's ammonium?
NH. Oh, polyatomic.
It's polyatomic ion, and its the symbol is what? NH4. What's its charge?
-1.
Not -1. +1. Okay, it's down at the bottom of your ion chart. It's the only one that is a +1. All right. Then, what is thiosulfate? S2O3, and it's a -2. Does that add up to 0? No, not at all. Okay? So you get rid of the positive, you get rid of the negative. The 1 would move down here. The 2 is going to move over there. Now, I can't put 2 subscripts next to each other. So what do I have to do?
You can put them in parentheses.
I can put one polyatomic in parentheses. You never really multiply it out. When you count the atoms, you multiply it out to count how many you have. Okay? So what you have is NH4 in parentheses, with a 2 as the subscript outside of it. Then you have an S2O3, and then the 1 is understood because I don't need another set of parentheses. Okay, are we okay here?
Yes.
Anybody have questions?
Yeah.
Shelby, set up your phone. All right. How do we get the formula mass? What do we do? What do we do, Shania? What's the first step?
You take apart each of the polyatomic ions. So N, you have to basically say there's 2 N's.
So there's 2 N's to be distributed, right? Times the mass of N. Okay.
And then with the H, since there's already 4 hydrogen molecules, you have to multiply the 4 by the 2 to get 8.
Yeah. Okay.
And then the S is 2, and then multiply that by the mass.
Okay.
And then O, and multiply the mass of
And I add it all together. Okay? And when I add all that together, what do I get? 140. 8. 240. And my unit is grams per mole. Okay. Are we okay here?
Yes.
Yes.
Okay.
Yeah?
Yes.
Yeah. Okay, what you got? Huh? So if it was 1 minus and 1 plus, I just put it together. I don't have any extra subscripts than what are already written in the polyatomic ion. All right? Huh? Yep. 48.24. All right? Then, it asks me for the percent S. All right? So when I solve the percent S, diamond in the room, you should have no reason to be rolling. It's the total mass of S. What's the total mass of S? 64.14. Over 148.24 times 100. 34.27. Or 43.27. All right. Are we okay there?
Yeah.
Okay, what's the question?
So yesterday we were doing this,
Mm-hmm.
and we had to make our own. When I kept dividing, no, we kept
That means you're dividing that down. It means you're dividing your formula mass by the total. It means you're putting this number in the calculator first. You're dividing your, instead of putting this in the calculator first.
Okay.
What you gotta like? If you were, this is still the right number of significant. Based on the data over there. For that element. But if you were doing significant figures based on the total number of elements, you would, or total number of digits, you would need 2. Which would just be 43. Only if I ask you. And right now I haven't. We okay here? Mm-hmm. Anybody have a question? Pause for a second. Alright, you asked. You want to know how polyatomic ion gets its charge. So, nitrogen is a -3, right?
Yes.
How many hydrogens are there in NH4? There are 4. What charge does a hydrogen have?
Positive.
+1. So if I add all that up, what do I have? -3 plus 1 plus 1 plus 1 plus 1. What's a really bad one? Stop! So when I add all that up, there's -3, -2, -1, 0, right? Plus 1. That's how it gets its total charge of +1 for a polyatomic ion. Because I add up its single parts. Because that's what makes up its bonds, right?
Yes.
Right? Its pieces. So you can do that for any polyatomic ion. You can add up its pieces and go from there. That's how it works. Has to work every time. And when they're negative, you add it up and you typically give it an extra electron. Alright. We okay there? So please, I don't mind answering extra questions. What gets frustrating, and where I turn into my, get my resting bitch voice on a little bit, is when I answer the same question about 15 times in a row, because you're just not paying attention. Because when I'm going over something, you're talking to the person behind you, or you're doing. Just pay attention. Pay attention. All right, where we're headed today. We're going to talk about objective 6, which is empirical versus molecular formula. We're going to talk about today. We're going to recap Wednesday and Thursday. So if there is stuff between any of the objectives, with the exception of objective 7, that after today you feel like we haven't covered good enough, that you want to go back over, write down your questions, and tomorrow and Thursday we're going to go back over them.
Yeah.
Okay? But it's not going to be a reteach everything. It's a I want focused questions. Then, starting Friday, we'll attack objective 7. We'll go through it bit by bit, I'll give everybody the packet for level 2 for objective 7, and then we'll go from there. Okay? All right. So, starting empirical versus molecular formula. A molecular formula is just a compound written the way you expect it, whether it be NaCl, CaCl2, C6H6, any of those. CO2, N2O4, NO2, yes, empirical formula. So molecular is just the way you expect any formula to be written, whether it's covalent, ionic, acidic, or later organic. The 2, the 6. Subscripts are the number at the bottom. Okay here? An empirical formula is the formula for the compound in the reduced, simplest format. And you can solve for it 3 different ways. So the first way use greatest common factor. Alright. So I'm going to give you a list of compounds. So we have C4H10, H2SO4, and N2O4. And then we'll do one more. We'll do C6H6. I'm going to try and write that one cleaner because it looks horrible. Alright. What's the greatest common factor on C6H6 between those subscripts?
2.
6.
6. Greatest common factor.
I thought you were talking about C4. We're not looking at C4.
C6H6.
Oh, okay.
Okay? So if you divide by the greatest common factor of the subscripts, which is 6, you can reduce that to CH. That would be the empirical formula. Okay? What about C4H10? What's the greatest common factor between 4 and 10?
2.
2. You can't divide 10 by 4.
Who is that for? Like,
2.
Well, you can, but you can't get a whole number. You have to get a whole number. Okay? So if you divide by 2, you're going to get C2H5. Okay? H2SO4.
2.
Not 2. 1. Okay, what's your question, Sam?
Okay, CO4 is so.
SO4 is sulfate.
Okay, so that's a polyatomic ion.
It is.
Well, when you put the sub, does that? I don't know how to explain what I'm trying to ask, but like you know how like you put them in parentheses and then you put like how many it is. I mean that's I don't know how to explain, but like you can't just change it and be like HSO2 because that wouldn't be sulfate.
Right. You're right. To where if I tried to divide this, I'd have half of a sulfur. Okay? I can't have half as a subscript. So the answer is 1. Okay? Alright. Hold on for a minute. Alright. What about N2O4? 2. I can divide by 2, right?
Because there's
Because the subscript on that S is a 1. All I have is 2, 1, and 4. Greatest common factor between 2, 1, and 4 is 1. Alright? So, that's option 1. That one seem okay?
Yes.
Yeah? Alright. We okay here? Can I move to the next slide?
Yes.
Alright.
What would someone use this formula for?
Okay. Sometimes with empirical formulas, you are given. You use it in baking a lot, believe it or not. Especially if you're scaling up or down a recipe to know how much to multiply up or multiply down. Masses when you cook.
Oh, yeah.
And measurements, and stuff like that.
Okay.
So it's one way to look at it. Is a comparative way to think of what it's like. What you got?
So when you divide it, like it has to cancel out. You can't like do like
Right, you have to get a whole number. You can't get a fraction.
okay, just making sure.
Yeah. All right. Option 2. You're going to be given a percentage. You're going to think of it like grams. You're going to divide it for a set of elements. Okay? Those percentages are going to be like percent composition. So you'll be given 2 or 3 elements. You'll be given their percent compositions. You're going to consider them grams. You're going to divide them by their atomic masses on the periodic table. That'll give you a set of ratios. You'll divide them all by the smallest ratio. And you'll get a set of numbers. If they're all whole numbers, you're going to stop. Those whole numbers are going to give you the subscripts for those elements for your empirical formula. If they're not whole numbers, you're going to multiply by what's called a factor to get a whole number. Like if you get 0.5, you're going to multiply by 2. Everything by 2 because 0.5 is 1/2. All right? So we're going to do 2 or 3 of these together so you see what I mean. Okay? Ready to try one? Okay. So let's say we have %, C, and I'm looking these up straight out of the textbook. 6.7% H. And 53.3% oxygen. All right. What would we do first? What do our steps tell us? Divide by the mass on the periodic table. So I'm going to say 40 divided by 12.01. Just something. You get 3.31, or 3.306 actually. What's the mass of hydrogen? 1.01, right? Mm-hmm. What?
You got 6.7, you got 6.67.
Oops. I wrote 6.7 in the calculator. Didn't write it on the board. Sorry. Good catch. Sorry about that. am I dividing by here? 16. All right. So I have 3.3306, 3.3313, 6.6337. Which one of those is the smallest? That one, right? Yeah. And really those two are essentially the same, right? For all intents and purposes. I'm going to divide them both, or all, by that. That's going to be 1. This is 1.99. This is 1.0002. Well, shoot, that's really just 1. 1.99 is really just
2.
2. So the formula for this one is C, because the subscript would be 1. H, how many?
2.
2. Oh. And it would be 1. Okay? We'll do another one. Does that make sense? It takes a couple. Let's try this one. .5%. NA 14.9%. SI and 60.6. F. Rudy? Divided by what? Let's see something mass at NA. 22.99. And you get 1.06. .9 divided by 28.09. 5304. And you have 60.6 divided by 19. $1,895. Which one am I going to divide by?
25.
No. That's a plus sign, Erica. Six point oh, I could call it 6. So it's Na2 Si F6. Now, you notice I said since it was 6.0, I could call it 6. Or since it was 1.99, I could call it 2. So when do you use those factors? Well, if you get 0.25. 0.25 means my fraction is what?
1/4.
1/4. So I would multiply everything by 4 to get rid of it. Because what I do to one, I got to do to the others, right? In math. If I get 0.5, my fraction is 1/2, right? So I'd multiply everything by 2. If I get 0.33, my fraction is 1/3, and multiply by 3. If I get 0.67, my fraction is 2/3, right? So I'd still multiply by 3. What if I get 0.2? 1/5, so I'd multiply by 5. Okay? So your factors are these. Still multiply by 2/3. Alright, so if you don't know your decimal fractions, you might want to write that down. Optional. What you got, Josh? You stretch. If you don't know your decimal fractions, that might be helpful. Let me make it neater. Alright. If you don't know your fractions in decimal form, you might want to write that down so you know what you're multiplying by.
It's the last one 67.
0.67. So that's option 2. Option 3. It would be the last option. It gives you an option where a problem might give you the molar mass. Now when they give you molar mass, they're talking about the molecular compound, the way it should be written. Then they'll give you the empirical formula. And they'll ask you to solve for the empirical mass, and then ask for the molecular formula. Or they can give you the empirical mass and the molecular formula and the molecular weight and ask you to go the other direction and give the missing two pieces of information. I've seen both happen. So, I'll show you how to do that. Can I flip? Yeah? Alright. So, molar mass, how it should exist. Empirical formula, how it exists reduced, right? So, an empirical formula has mass. I can calculate just like I do molar mass. So, since they didn't give me this in decimal form, I'm not going to solve this in decimal form. I'm just going to round. So, what's the mass of hydrogen? 1. What's the mass of carbon? 12.01, right? So I'm just going to say 12. What's the mass of oxygen? 16. How many of them do I have? 2. So 2 times 16. So that's 13 plus 32, which is 45, right? So the empirical formula mass is 45 grams per mole. What's the ratio if I were to compare the two? How many times does 45 go into 90? Twice, right? So the ratio is 1 to 2. What can I do to find the molecular formula then? What do I do to this formula?
Multiply.
Multiply by 2.
Yeah.
So the molecular formula is going to be H2C2O4. Do you see how we did that? Where did I lose you?
Where's 12?
Huh?
The 12.
Okay. Atomic mass. Atomic mass of hydrogen is 1, right? Atomic mass of carbon is 12. Atomic mass of oxygen is 16. I got 2 of them from that subscript. Add it all up, I got 45. Technically it's 12.01. Technically it's 1.01. But since they didn't give me decimals here, I wasn't going to worry about decimals over there. I added up, I get 45. And then I determine how many times 45 goes into 90. Well, it's 2. So a ratio of 1 to 2 means I multiply this whole thing by 2 with the subscripts to find the molecular formula. That one seem okay?
Yeah.
Yeah. What you got then? You sure? Want to try another one? Alright. Let's try another one. Let's do this one. C2H4O is your empirical. The molar mass is going to be 88 grams per mole. I'm going to hit pause for a minute and let you do what we just did and solve it. And we'll come back and we'll check your answer. What do we know?
Well, the first one is as is.
So the empirical mass is 44 grams per mole, right?
Yes.
So you should have gotten
I got
That's the ratio.
1, 2.
ratio of 1 to 2 again. So you should have gotten C4,
What day is it?
8,
Right there.
0,
What you said,
2.
Cheryl?
Hey, I got it. I got it.
Hey.
First time.
For the molecular formula. Alright. So,